Are we? Great. So we are live, Tanya. Welcome to everyone. We have now another exciting keynote with Tanya from VMware. Welcome to the stage, Tanya. We are 3 minutes late, so don't you worry. We'll have another 3 minutes more with Tanya. So, Tanya, the stage is yours.
Thanks so much, Victoria. It's wonderful to be here. And hello, everyone. Good evening. I'm Tanya Shastri. I'm VP of Product for Blockchain at VMware. And I'm very happy to be here today to talk about blockchain in the enterprise and to share our thoughts on bringing, enterprise-grade applications into production. To get started, before we start, especially for those who aren't familiar with VMware, I have a very brief introduction. VMware has a long heritage, over 20 years of delivering innovative technology, software, and software as a service to our customers so that our customers in turn can innovate in their businesses. And it is through this experience that we have a deep appreciation for what it takes to bring business critical applications to production and then to continue to manage them, operate them, and so on in production. And then also here, I'm just sharing a few examples of the experience that I'm drawing on to develop our viewpoint on bringing applications to production. We have been partnering deeply with industry leaders in the DLT space with our product VMware Blockchain. And it is through this experience of these engagements that I intend to share how leading enterprises are leveraging DLT-based solutions, bringing them to production and transforming their industries. So for example, we have collaborated deeply with Broadridge Financials, one of the leading financial services, financial market infrastructure providers, on developing their distributed ledger repo platform. This is underpinned by VMware Blockchain. It is live, it is in production, delivering over 35 billion in daily average volume, and it continues to grow. And they're really transforming a critical business function, a critical financial market function of repo transactions and repo agreements using this distributed ledger repo platform. Similarly, and then I'll just also mention Australian Securities Exchange. Their application called Chess Plus is leveraging VMware Blockchain, and that Chess Plus application is modernizing their entire post-trade clearing and settlement functions. And this underpins the entire Australian equities market. And this has gone into industry-wide testing in November this year and is starting to open up to the industry so that they can now start using the platform and trying out and putting their applications onto the platform. Another example is their Symphony product, which is a DLT as a service platform. So what they're doing is they're offering DLT as a service to their customers in the entire Australian and New Zealand markets. And this is powered by VMware Blockchain. It's driving a completely new business revenue stream for them. In addition, we're also collaborating with customers like Deutsche Börse, Bursa Malaysia, and others in their journeys to fully dematerialize and digitize assets. So these are some examples on which we're drawing our experience and sharing with you what we are seeing in the industry. So first off, when we are talking to customers in the space, it's becoming clear that there's a much better understanding that DLT provides value in a range of use cases. And all of them have somewhat of a similar problem statement, right? If you look at all these examples on the left-hand side here, and this is not complete, it's just an example of them, whether it's bond issuance, clearing settlement, supply chain use cases, carbon credits, digital identity, so on and so forth. Several of them, either they exist today or are done in ways that are pretty outdated. These multi-party systems use architectures that have silos between the parties. Each party has their disparate data and processes and so on. Messages need to be sent between the parties and when they interact, and data reconciliation is required across all these parties. So it's pretty inefficient, leads to errors, pretty slow, multiple manual steps to recover from errors, increased cost and business risk, right? And the situation is only getting compounded because of things that, there's increased growth demands, costs are increasing, competitive pressures, and so on. And it's quite clear that blockchain can really transform these multi-party applications with these core aspects, right? The shared and trusted source of truth that all parties can trust, mutualized workflows so that processes can be automated across these multiple parties, and the programmable asset aspects that allow for the assets to be more intelligent and to actually trigger the processes across all parties, and so that it's done in a way that that the process can also be trusted. At the end of the day, reducing the operational cost, the business risk, and generating new business revenue streams. So this is all great, right? There is a clear understanding of the value, and then as customers are looking to now bring some of these use cases into production, this isn't enough, right? There's more that needs to be taken into consideration. So what are some of these things that enterprises need to take into consideration as they think about taking these core primitives that are being delivered by blockchain and DLT and then bring them into enterprise grade solutions? So here you see privacy, of course, is very important. For business reasons, for regulatory compliance reasons, privacy is always an important functionality to have. Performance. These, we're talking about very high volume use cases, high throughput, low latency requirements with many millions of transactions per day. Efficiency is very important. Many of you are familiar with the inefficiency of proof of work mechanisms for consensus and the industry moving to proof of stake and so on. You'll see my background here with the tree. VMware, my company, is very environmentally conscious, and definitely, our consensus mechanisms, our efficiency is to move further beyond even the efficiency of proof of stake. Capacity management is, I'd say, the next one. I'll go into a little bit as we discuss it further as well. The predictability of costs with gas price fluctuation and so on, these things make it very difficult for enterprises to run their business. So these are all considerations that need to be taken while going into production, right? And these are the kinds of things that have to be addressed prior to going into production. Over and above that, I'll just add, the space is rapidly evolving. There are many new things happening. So thinking of the flexibility of the platform, the extensibility of the platform on which these smart contracts and applications can be run is also an important consideration. And how simple and easy is it to manage and maintain? Because already there can be complexities when you're moving into a new space and offering new services and changing the paradigm and transforming things. How do you kind of reduce the areas where there is complexity? And then, of course, the requirement to have very extreme robustness, right? These are things that we don't want going down. They can have impact to businesses, impact to the entire ecosystem, and having the right robustness and the right support behind these solutions is also pretty important. So while I've given a quick overview of some of the things that enterprises need to consider in addition to the core blockchain capabilities, I want to highlight a few here that we come across more often and that I'd like to just bring to everyone's notice, right, as important considerations for production. One is capacity management. There's this expectation in some ways that blockchains and distributed ledger technology, the data that's put in is immutable, and you don't take data off the blockchain. But when we're talking about use cases where multiple terabytes of data are being put into the blockchain, and where a lot of the data has to be maintained on chain to get the data integrity and the verifiability and so on, we really need to have a way to prune data off the primary blockchain, but then do it in a way that is still consistent with the core principles of blockchain, so that you can maintain the full history of the blockchain in what we call kind of a full copy client node, right? So doing that and then also at the same time, ensuring that capacity management and pruning is done with consensus, so that all nodes in the network have participated and it's done through the right types of governance. So capacity management is something that needs to be thought of early and needs to be planned and designed into the system, and the infrastructure needs to be capable of doing it. So I'd say capacity management is an interesting one, especially for high volume use cases. And we are seeing several of those already. The ones I described that we're drawing our experience on are certainly in that category. I'll also mention upgrades. So upgrades as well, for all of us familiar in the blockchain and DLT space, upgrades are quite unique. The entire system has to be upgraded, again, with consensus and meeting the right primitives of the blockchain space. And it has to be done with data continuity across, there's aspects of the smart contract that may require upgrades, the blockchain infrastructure that might require upgrades, and how is it done in a trusted and authenticated way, as well as with data continuity. And then, without having the complexity in this and making it unwieldy, right? Because as we expect in the early days, given there may be more features and functionality that need to be added to the smart contract or what have you, upgradability is an important consideration. And again, considering it early and planning and designing for it early is something we highly recommend. And then the third one I picked was reconfiguration. When we are seeing these blockchains networks evolving and the market participants participating, these are growing ecosystems, and market participants have to be added. Scalability considerations have to be taken into consideration. Oftentimes to meet business goals, you may want to start smaller and then grow as the market participants and the adoption increases. So being able to reconfigure and scale up, potentially scale down in some cases, depending on the business requirements, these are the things that also have to be considered early in the path to production. And how is reconfiguration also done in a way that stays true to the blockchain primitives, so that it is done with consensus, done in a trusted and authenticated fashion, and done in a way that meets the blockchain primitives. I think these are things that are important considerations to keep in mind, or at least certainly some of them. And I don't want to miss the point about having robust end-to-end support, because in some cases there are several pieces coming together. There is the infrastructure side and the actual blockchain itself. There is the smart contract. There are aspects of an application or a user interface that may be layered on top of the smart contract. Integrations with other tools and technology in the enterprise, and really having an end-to-end support plan across that entire piece is again extremely important, so that if and when issues do occur, there is the ability to go in very quickly, find what the problem is, and resolve it effectively across that ecosystem. So I do want to kind of share a little bit about VMware blockchain and what are we doing to help bring our enterprise customers' products to production. And there are some unique things that I'll just talk about in the context of our product as well, which add to a few things to take into consideration as you go to production. So first, very briefly, a little bit about our approach to blockchain. We VMware have a lot of innovative technology. So we have really built this from the ground up. There is unique research that has come out of our labs. That unique research has been productized, and that is what we are bringing to market. So this is, from the ground up, built by us. It isn't borrowed open source code and so on, right? Key aspects that I talked about efficiency, cryptography, performance, fast transaction finality, granular privacy with physical data segregation. Those are all some of our key innovations that we have brought that are very core to enterprise use cases. We have taken that innovative technology and packaged it into a platform, with the perspective here really that we want to abstract away all the complexity. We don't think everyone needs to worry about all the blockchain technology and all the complexity. We want our customers to be able to focus on the applications they're developing, on the smart contracts. That's really where those are the pieces that are core to their businesses. And if we can take off the complexity and the burden off them for operating the infrastructure underneath, that then really becomes win-win situation. So we've designed our platform to be that kind of an extensible and simple platform to use. And then, of course, what we really are also very aware of is that extreme robustness requirement. No one wants to be in the news for something going down or for something not working. And these end-to-end testing and the test harnesses we have, resiliency in the case of extreme disasters, resiliency to malicious threat. That's a very key piece of what we do. And performance and under sustained stress, right? So even though there are situations with stress, the performance continues to be maintained. And overlaying on top of that are enterprise grade support, which is very natural to VMware to do, given the extent to which we support our global customers already. So really, we kind of take this into consideration as we build our product to stay very true to the blockchain primitives. And I will kind of just move on to this layered architecture view. That foundational layer really is where we have our unique blockchain specific technology, which is at its core, we have a Byzantine fault tolerant, malicious fault tolerant consensus mechanisms with finality, fault tolerance, reconfiguration, upgrades, all in that core blockchain platform, along with our granular privacy as part of it. We then create what we call virtual execution environments so that you can run multiple smart contracts, and not just multiple smart contracts, you can run them in multiple smart contract languages. So we have support for DAML in production, for Ethereum, and we also then can extend our platform to have various other smart contract languages supported. We take this and we really, at the end of the day, we create a very standard interface on the top. So the DAML Ledger API or the Ethereum JSON RPC API are very standard for what the industry can expect, so that the smart contracts developed in those languages can be very easily ported over to the platform, or all the tools and technology that exist for developers and developer environments can be leveraged. And then at the same time, you can run those applications. If we take an Ethereum example, things like the efficiency, the transaction finality, performance and throughput, things like privacy, and also things like I mentioned several of them. I'm missing one of the key points. Yes, the gas price volatility, right? Those are kinds of things that make it hard for enterprises to run their business. And by doing those things on a platform that enables you to get around those kinds of issues is a good consideration to be aware of, right? So I just wanted you to be aware of that. And then, the point I made about this end-to-end support, that's really, again, the point to make here, that we want to take care of this entire piece from a support perspective so that our customers can then work primarily on the applications, focus on bringing those applications, the features and functionality that they need to provide to the ecosystem. All right, I want to share a little bit here now about how that architecture that I shared in the previous slide is actually deployed in real life, right? This is what it would look like. You'll see on the right-hand side, we have what we call our replica network. This is the Byzantine fault-tolerant replica network that is malicious fault-tolerant. You'll see that there are multiple nodes in the replica network. These multiple nodes all look alike. So it's a simple, from a deployment perspective, several replica nodes that all look alike. And then we have client nodes, which really help the application, help the participants to connect into the replica network. And it's just those two types of nodes. It's a very simple architecture. The replica network doesn't have a special database layer or doesn't have special ordering service or notarizing service or anything like that. All that functionality is natively in the replica nodes itself. So it is a seamless experience to manage and monitor across all of them. And there are no extra middleware functionality that the customer needs to worry about. So this not only makes it simple to deploy and manage and so on, it also allows for scalability to be done in various ways. As more clients are added, just the client nodes can be increased and the network can be reconfigured for additional client nodes. As the network wants to scale in terms of where clients want to operate replica nodes as well, the replica network can be scaled independently. So it's both kind of the the ease of use, the ease of support, the ease of deployment, as well as the scalability that become simple given the simple architecture. I did want to share this point with everyone as well, because it's a bit unique, and it's also very interesting as our clients are bringing solutions to production. There are multiple ways in which the network itself can be operated. So there are 3 ways here that I'm showing. On the left-hand side, you'll see that there's a single operator operating, the core replica network, as well as the client nodes. And then there are options as you go to the right where the clients can operate their own client node, or they may even choose to operate one of the replica nodes, depending how they want to participate and to the extent they're willing to take on some of the operational burden. But when you think about going to production, you think about trying to reduce the variables and increase the rate of going to production, we're finding that the left-hand side is typically where is a good place to start, because there the market participants can benefit from the blockchain primitives, can be on the same mutualized infrastructure, have a single shared source of truth, have a single shared automated workflow without necessarily having to take on the operational burden. That becomes quite a good win-win situation where a trusted third party, sometimes even a JV or so on can be created so that a centralized operator exists and the entire ecosystem can benefit from it. And then moving on to then decentralize it further and further as the journey goes forward. And again, that's one thing that our architecture is able to provide, given the fact that we have both this the DLT node as well as the client nodes involved. And it also brings about the way for doing a lot of privacy with data segregation, so that each client node can have its own subset of the data, and we can do fine granular data segregation between the clients, so that each client has only the data that it is privy to and does not need the view of all the data on the network. I will just have one final slide before, if there are any questions, I'm happy to take them if we still have some time. But there's this ease of day 2 operations at the end of the day. When you go to production, of course, getting to production is always an interesting milestone, but then this is the long-term management and operations of the product in production, and the day 2 operations aspects of monitoring and logging, choice of consumption so that you can put it either on premise or in the cloud. The capacity management and upgrades and support that I already mentioned are all very key to how we deliver successful outcomes for our customers. And I just wanted to share this brief overview with all of you, and hopefully share some familiarity about the work we're doing at VMware Blockchain. There's a lot to share more, and we'd love for you to reach out to us. Here are some ways you can reach out, either via email through Ask VMware Blockchain at VMware. We also have some locations at Twitter. You can DM us or go to our website. And really appreciate being here at EBC. And I will go back to Victoria.
Thank you. Yeah, sorry for interrupting you. Yeah, we are over time, Tanya. Thank you so much for a lovely keynote. Albert has answered a few questions. I've also forwarded those questions to the chat box. Thank you so much, Tanya. We now have to continue with our last panel of the day, the future of crypto exchanges. Thank you, Tanya, and everyone. See you in a bit.
Thank you so much. Bye-bye.
Bye.